coming to you live from Bugsphere. Foundations of Math and Pre-Calculus 10. Dance. Today, sections 2.4 and 2.5, the sine and cosine ratios. Alright, when we are working with right triangles, we have seen that using the tangent ratio, the Pythagorean theorem, and the fact that the angles must all add to a sum of 180 degrees can work very well to find the missing side lengths and the angles. But in all of the cases that we've done so far, we've been given information about one or both of the legs and never about the hypotenuse. Today, that all changes. For example, with this triangle here, triangle PET, we could easily calculate angle T as 23 degrees, but our old friend the tangent ratio isn't going to do us any good here, whether we're working from angle P or from angle T, because as far as the opposite or adjacent go, we don't know either of those bits of information. Even good old Pythagoras can't help us out here without at least one of the two legs given. So we need a new trig ratio. We need something that will compare the hypotenuse to one of the legs, whether it be the opposite or the adjacent side. Unfortunately, just such a thing exists. So for sine, cosine, and tangent, these are what we would call the basic trig ratios, the three basic trig ratios. And for an angle theta in a right triangle, the following ratios are defined. We say that sine theta is the opposite over the hypotenuse. Cosine theta is the adjacent over the hypotenuse, and tangent, we already know, is the opposite over the adjacent. So to calculate the missing side lengths in our original triangle PET, we could now work with the sine or cosine ratios from the angle of 67 degrees. So if we said the sine of 67 degrees is opposite over hypotenuse, that opposite side is this little p here. So we have little p over 14, that is opposite over hypotenuse. Solving for p, hey, we need to multiply both sides by 14. We get 14 times the sine of 67 degrees equals p. Grab our calculator now and type in 14 times sine 67. Enter. We are getting approximately 12.9 centimeters for side little p. We'll go to one decimal place in this question today. So p is approximately 12.9 centimeters. Now, to get the other side, little t over here, we could do Pythag, or since we've just learned about this new thing called cosine, why don't we try working through an example with the cosine ratio? So the cosine of 67 degrees is the adjacent over the hypotenuse, or t over 14. Multiply both sides by 14 to isolate the t. That is 14 cos 67 degrees equals t. Again, grabbing the calculator and saying 14 cos 67. You don't need to put the times in like I did the first time. And we get little t is approximately 5.5 centimeters. Like we said before, at the beginning, you could also find the measure of angle t by subtracting from 180 degrees and getting angle t to be 23 degrees. And you know, we could have actually done the sine from angle t with its opposite over hypotenuse, or the cosine from angle t. It doesn't really matter which one you do. They're all things that are in play. You just have to choose to do one of them. All right, let's give this a try here. Consider triangle TRY and give each of the following. Sine of angle t. Remember that sine of angle t, sine is always the opposite over the hypotenuse. So if we're looking from angle t, its opposite side is 5 and the hypotenuse is 13. So the sine of angle t is 5 over 13. If we're looking at the sine of angle y, again, opposite over hypotenuse, from y, the opposite side is 12, and so opposite over hypotenuse here is 12 over 13. Cosine of angle t, cosine is adjacent over hypotenuse, and so if we're going from angle t, its adjacent side is actually 12, so we have the cosine of angle t is 12 over 13. And we have the cosine for angle y being adjacent over hypotenuse as 5 over 13. Then we've got the tangent of angle t. Tangent, we already know, is opposite over adjacent. That is 5 over 12. And the tangent of angle y, opposite over adjacent, is 12 over 5. So two things here that I want to highlight. We've already spoken about how the tangent ratios of these two angles, t and y, will be reciprocals to each other because opposite and adjacent change position when you change perspective of which angle you're talking from. I want you to also notice, though, that the sine of angle y and the cosine of angle t are both 12 over 13. And that the sine of t and the cosine of angle y are both 5 over 13. And this will happen, in fact, anytime you've got two angles that add up to 90 degrees. The cosine of one of those angles will be equal to the sine of the other. For instance, the cosine of 10 degrees must be equal to the sine of 80 degrees. Give it a try now on your calculator. Test that out with any two numbers that add up to 90. Test the sine of the one number and the cosine of the other number. You'll see that those two things are equal. The last thing here for us to do in this question is to find what the measure is of each of these angles. What is angle t? What is angle y? Let's get our calculator again. And now to get angle t, I can pick any one of these three trig ratios that we had and do the inverse ratio for it. So whether it's sine, cosine, or tangent, all three of them will work. And I do it by saying inverse sine, so second sine, and I can just type in 5 over 13, 22.6. Want to test it out with cosine? 12 over 13. 22.6, and I could do the inverse tangent as well, but I know that this is going to work. I've got angle t is 22.6 degrees. Now solving for angle y, I could simply subtract from 180, but since I've got these new trig ratios, sine and cosine, I'd like to test them out on the calculator as well. So let's do the inverse sine of 12 over 13, getting 67.4. Or let's do the inverse, let's try tangent this time, of 12 over 5, 67.4. So we know that angle y is 67.4 degrees. And now, something for you. A 20-foot long ladder is leaning against the wall of a house at a 75-degree angle. So let's imagine we've got this ladder here against the house, so that it creates with the ground a 75-degree angle right in there, 75 degrees. The ladder itself, that's this guy here, is 20 feet long. What other information can be determined based on this? Let's assume, just for the sake of this question, that the ground and the house are meeting right here at a, let's go 90-degree angle, kind of your standard thing. House coming out of the ground at a right angle. I know, it's crazy. Get all the other information that you possibly can about this ladder and its leaning against the house. That's all the time we have for today and all the content we have as well. Tune in next time when I'll say something